This is the second functions video, following on from the first one where we introduced the words domain, codomain and range, and this one is all about mapping diagrams and how they work. So here what we have is we have what a mapping diagram is, and a mapping diagram just kind of looks at the domain, the codomain and the range of each of a function to see how it works, and it's just a way to visualize a function and hopefully make it a little bit easier. So the set A, so this guy over here, is the domain. Set B is the codomain. And the set of elements that get pointed to in B are the range. So here we have a function, and the function is, if you put in x, what you're going to get out is you're going to get 2x plus 1 out. So for example, when we put in 1, it's going to be 2 times 1 plus 1, so the answer is going to be 3. So that's why we have the arrow here from 1 to 3. So making sure, what is the domain? The domain is what we put in. The codomain is what we could get out. We don't have to get all the numbers out, but we could get any of the numbers. And the range is what we get out. So in this one here, the domain is what's put in. So the numbers that are put in are 1, 2, 3, and 4. So they're the domain of the function. The codomain are the numbers that could come out of the function. So 1 through 10 here in the codomain. And then the range are the numbers that actually come out. So you can see that the arrow is pointed to 3, 2 is pointed to 5, 3 is pointed to 7, and 4 is pointed to 9. Now, bearing in mind that a function always has to have an input that only has one output. So a function is not a function if, for example, this 4 was also pointed at 10. So a function, every input of a function has to have only one output of a function. That's the key thing. So the key definition of a function is every input has only one output. So a function may also be written as ordered pairs. So for example, in this one, the ordered pair would be 1, 3, 2, 5, 3, 7, and finally 4, 9. So another one here, so we can see they've given us two examples here. So we have 1, 4, 2, 5, 3, 6, and 4, 7. And this is a function because no two ordered pairs have the same input. So for example, 1, 2, 3, 4, they all have different outputs. So for example, 1 is only mapped to 4, 2 is only mapped to 5, 3 is only mapped to 6, and 4 is only mapped to 7. However, if you look at the next set of ordered pairs, it's not a function, because if you look here at the 3, so 3 is mapped to 8, but 3 is also mapped to 9, and the definition of a function, one more time, is a function is a rule in which an input can only have one output. So an input can only have one output. So 3 here has 2 outputs, so this can't be a function. Now, so an example here, we have question 1.8, and says, state whether each of the following mapping diagrams is a function. Give reason for your answer. So in the first one here, A, B, and C, just to get used to the terms, so our domain is what can go in. So the domain of this function is A, B, and C. The codomain is what could come out, which is D, E, and F. And the range is what actually does come out. So what actually comes out of this is D, E, and F. So what you can see is sometimes the codomain and the range can be the same thing. But over in this one here, we have the domain. And the domain for this one is 1, 2, and minus 2. And we have the codomain is what could come out, and it's 1 and 4, and again the range is also 1 and 4. Now back to the question. So state whether each of the following mapping diagrams is a function, given reason for your answer. So we want to see if this is a function. So bearing in mind that a function, so each input can only have one output. That's the definition for a function. So you can see in the first one here, so A maps to D, so A only has one output. B, however, though, so B maps to E and to F. So A is not a function because B has more than one output. I'm hoping that's okay and makes a bit of sense. Now, so B, bear in mind, so each input can only have one output. So here 1 maps to 1, which is perfect. 2 maps to 4, so the input 2 only has one output, which is 4. And minus 2 maps to 4, which is also fine because minus 2 has only one output. So B is a function. And the reason why it is a function, because each input only has one output. Now, so a lot of people get confused and they might not agree with me just yet because you can see here the number 4. So 4 is there for two numbers. So 2 maps to 4 and minus 2 maps to 4, which is perfectly fine. The problem is if it was the other way around. So if 4 mapped to 2 and 4 mapped to minus 2. So an output can have two inputs, but an input can't have more than one output. I'm hoping that is making a bit of sense. Now, and the final question example here, we have question 1.9. So it says, for each of the mapping diagrams below, write down the domain, the range, and the codomain. So first of all, we'll do A. So the domain here, so remember that the domain is what goes into the function. So the domain here is 1, 2, 3, 4, and 5. The range, remember, is what actually comes out of the function. So here it's 3, 6, 9, 12, and 15. And finally the codomain. The codomain is what could come out of the function. And what could come out of the function is 3, 6, 9, 12, and 15. So again, here we have the range and the codomain are the same. For B, the domain, again, the domain is what we put into the function. So the domain is 1, 3, and 5. The range is what actually comes out of the function. So 3, 5, and 7, they come out of the function because the arrows are mapped to them. The codomain is what could come out of the function. So in this one, it's 3, 5, 7, 9, and 11. So again, the domain is what is put into the function, the range is what comes out of the function, and the codomain is what could come out of the function. Now, just two other examples, just to kind of hopefully clear any misconceptions up and make sure that people are kind of okay with everything that's going on with the function so far. So, are these functions? So the first two we have here are ordered pairs. So remembering that the one on the left is what goes into the function and the one on the right is what comes out of the function. So if we put 1 into the function, we get 4 out. If we put 2 into the function, we get 5 out. If we put 3 into the function, we get 6 out. If we put 4 into the function, we get 7 out. Now remember, key thing, and I'm going to keep saying this, what is a function? So it's where an input can only have one output. So if we look along here, so we've input 1, an input 2, an input 3, and an input 4. So there's only 4 different inputs. None of them are the same. So this is a function. So the first one is a function. The second one then, so we have 1, 3, 1, and 4. So you can see here that an input can only have one output. Now 1 maps to 3 in this one here, and 1 maps to 7 in that one there. So this one is not a function. And the reason why it's not a function is because an input can only have one output, whereas 1 here maps to 3, so the output is 3, and 1 also maps to 7, so the output is 7. So 1 has 2 outputs, so it can't work. Now, so if you look at this mapping diagram over here, it's the exact same thing. So is this a function? The first one at the top. I know my drawings aren't the best, I apologise. But we have here the input, there's 3 dots, and an input can only have one output. So the first input is mapped over here, the second input is mapped again up to the top, and the third input is mapped over here. So yes, this is a function. One input doesn't have 2 outputs. If If you look at the second diagram here, we have two inputs. Now, but one of the inputs is going to two different outputs. So no, this is not a function. And the reason why it's not a function is the input, the second input, can only have one output to be a function, but the input here has two outputs, so it can't be a function. And the final one here, we have 4 inputs, and the first two are mapping to one point, and the second two are mapping to another point. So is that a function? Yes. And the reason why it is a function is because the inputs can only have one output, but the output that they can have can be the same. So that's perfectly fine. So I'm hoping that's cleared up a little bit of maybe misconception that might be going on. If you do have any questions, send me an email and I'll get back to you straight away.